heard of ACDC?
Yeah.
Well, that's where that comes from.
Really?
Yeah.
So ACDC comes from the phrase, or does the phrase come from
The band ACDC is named after.
Right, yeah.
The electrical energy. Yeah.
Wow.
AC, alternating current.
So all of the stuff that comes across the power lines is alternating current. Whereas all of the stuff that comes from a battery is, guess what?
Ripples.
Direct current. Alternating or direct. So direct means it's flowing in one direction, and alternating means it's flowing in backwards and forwards.
Still the power company sends it over the wire to the house.
Which is wrong.
Tell us why, Lucy. Tell Freya why.
So there's no electricity in the wire until the power company sends electricity over the wire. The power company has a generator, and so there's all the neutrons and electrons in the wire, and so the power company has a generator and it pumps stuff through the wire, pumps.
It just pumps back and forth.
It pumps.
Like that, doesn't
And,
it? It
and
moves.
that makes the electrons and neutrons move like this.
Or jiggle.
Yeah, jiggle, because you're like, what you said in the hose, it pumps the water to make the water come out of the hose. That's like with this, except they just jiggle back and forwards. And then that creates energy. Is that right?
Yeah. So it's not like a hose, it's the opposite of a hose.
Oh,
The hose is pushing the water through.
But this is just making
But
it
we've
jiggle
got-
back and forth.
It's a hose that both pushes for a little while and then pulls back.
So
So
it goes like this. It's like if you drag your finger through water. Yeah, this.
Yeah.
It'll just go forwards. The water just jiggles.
and just to give you an idea, right? Just to give you an idea, when we're talking about that jiggling backwards and forwards, it's not the distance that the electrons travel is tiny. It's about 1,000th of a millimetre.
Do you remember we talked about the tortoise last time?
Yeah.
How
It goes slower than a tortoise moves. Slower.
and
No, we see light come on instantly because we turn it on. We're going to talk about why that happens.
so the jiggling is actually very slow, and it's only a tiny little distance that it moves. It's hardly anything, right? So it's not like a big distance and then
So
a
there's
little
an
one.
electron somewhere in that little bit there, right? That when there's a generator attached to the end and the switch is on, when the switch is on, the electrons there are just going there. And they're pushing some of the ones that are next to it back that way, and they're pushing the ones on this side this way. And the next one's jiggling like that. So it's not like one electron travels through all the way to the end. It just goes up and down. Just like the wave in here went up and down, the ball went up and down, didn't
And
it?
so what does that create?
Well, the jiggling, what do you think the jiggling creates? A good question.
Electricity. I was going to say energy.
Yeah, it's a type of energy.
Electricity is the...
It's a type of
So
energy.
that creates energy, which then flows through the wire.
Well, the energy does, yeah.
Yeah.
Because that energy
No,
goes out.
it doesn't.
So,
Flows
No,
above it in waves.
So the
no, go. You go.
so the electrons and protons are like they're in the wire, and then so when the power company generates, like they turn on the generator, it jiggles the electrons, and so that just makes sort of like a domino effect.
Effect. Oh, yeah.
That's right, isn't it?
And
then
they just
it
topple
jiggles, the
over,
electrons jiggle in the
and then
wire.
when it gets to the light,
So one domino doesn't go all the way
yeah,
to the end.
it doesn't go that.
It just pushes the next one, which pushes the next one, which pushes the next one.
Is that
That's
what's
jiggling.
happening with the...
Jiggling.
Yeah.
That'd be accurate.
Yeah, there are two things that you need to not confuse, okay, which is often what people do confuse. And it wasn't accidental that I asked you that question. So when we flick the switch on and we look at how long it takes to turn the light on, is that a long time or a short
Very
period?
Short.
It's fast or slow?
It looks
It
fast.
looks fast, but it's slow. To us, it looks fast.
Yeah, but it's actually really, really slow.
Well, what we've just said was that is it the electrons moving from the switch to the light?
No, it's the energy waves that you generate.
Yeah.
Going over the top of the wire.
So what is it when we turn that light globe on? What is it that travels very quickly? Something travels very quickly.
The energy, the waves, energy. The waves, yes, above around the wire.
If we're talking about what makes that light globe glow, or what makes a heater heat, or whatever it is, that requires energy to do that, right?
Yeah.
And so it's electrical energy. It's not electricity. Right? Say if you were heating something with a fire and you were burning the fire, and you say, what keeps you warm? And it's the flame, it's not the wood, it's not the coal that keeps you warm, it's the fire, it's the flame. So it's not the electricity that makes the light glow, it's the electrical energy that makes the light glow. The electricity is all of the stuff in the wire, and the electrical energy is what comes from the waves. It's not the water that makes this move up and down, it's the wave that makes it move up and down. Now also, the water wasn't moving really, but the wave travelled. So the wave travelled a lot faster than the water. The water basically stayed where it was.
Yeah.
And if we'd have been pushing the water backwards and forwards, it really wouldn't have moved very much, right? So, back to this. We've got a wire that goes, so this wire actually goes from the switch, one side, and back to the generator. So it comes from the generator to the switch. When the switch is off, there's a break in the wire. So all of the electrons from this switch back to the generator are all jiggling, all the time, even when the light's off, right? But because these wires are not joined, nothing's happening in the
So when the switch turns on, does it make the wires connect?
Yeah.
And then everything jiggles.
But when the switch is not on, it's an open circuit, so the electrons can't create the domino effect.
Does that make sense?
Yeah. Is it like if you put your hand in the middle of a stack of dominoes and you did it, but then you can't keep going?
Yeah.
Or if you put a plastic wall here, right?
Then it can't.
And the switch is on this side.
But then you took the plastic wall away.
Yeah.
And is there, so even if the switch is off and it's not connected, are there electrical waves on this side just waiting to go to that side?
Yeah.
So it's like
Is it what is it? Waves that are waiting to go? What's waiting to go?
The switch is waiting to turn on. So then
Electrical
Yeah.
energy.
So the electrons are jiggling.
Energy.
What happens is, you talk about dominoes, okay? Instead of thinking about dominoes, think of marbles. So you've got marbles stacked up on a groove, right? So they're all in a straight line, and they're all touching each other, yeah? And so what happens is that if I move one marble down there, if I had a long groove of marbles all the way, right? And I push a marble at one end and they're all touching, how long would it take before I felt the marble at this end move? Just about instantly.
Yeah. Because that marble moves and moves them all.
Yeah. So if you thought of that as electrons, so all of the electrons are like marble. So when the generator pushes an electron there, it almost
Because they're all
instantly,
touching.
yeah.
Creates electrical energy.
Yeah, so as soon as the generator's turned on, it pushes a marble at that end, and almost immediately, but have any of the marbles really moved very much?
No.
Can I show the Eureka conduction video? The molecules, the vision of that, see how the heat travelled. So it's the heat energy that travelled, not the molecules themselves.
Yeah.
It's not the spoon that travels,
It's not the spoon.
it's the heat travels through the spoon. So it's not right to say that the spoon is the heat.
So the wire is not electricity.
Yeah.
It's the...
And even to say that
It's an
there is
electrical...
electricity in the wires.
It's the movement?
The
Is that
electrical
the-
energy. Yeah?
Yeah, but the electrical energy, where did we say that it was? Was it in the wire?
The electrical energy.
We said it
No,
was-
that gets created. That creates.
Where is it, Lucy?
There are It's on top of the wire.
On top of the wire.
It's outside the wire. It's trapped, but it travels outside the wire, right? It's like it's invisible, like it's magnetism. There are ways that you can see it. Now, there's one other thing that I've got to tell you, okay?
Is that a question, Lucy?
Yeah.
Go quickly.
So what is electricity if it's not the molecules? What is it?
It's electrical.
It's
It's electrical energy is waves.
No, just the confusing thing that you've got to get straight is electricity, right, is the physical stuff. The electrons, the protons, all of the atoms in the wire, right?
That's electricity.
It's the physical stuff, the stuff that if you had a nice magnifying glass, you could really see it's something real, okay?
Yeah.
But that is not what makes the light globe glow.
It's the electricity.
That's
It's
what
the electrical
carries in the
energy
same
that's
way.
created by the electron.
In the same way, it's not the spoon that provides the heat. The spoon is just providing an easy way for the heat to travel. So what happens is that someone applies energy, so you put the spoon in hot water, right? So the hot water makes everything jiggle. And when it jiggles, it's just like you jiggling. If you keep doing it, you'll get warm.
Yeah.
Right? It's exactly the same. If you stand really still, you get cold, right? So the electrons are the same. There's electricity, so the electricity is all the physical stuff in the wire. That's the electricity. Then you've got electrical energy. So the electricity is the physical stuff.
The electrical energy is the waves.
So
Yeah, and it's like...
And where are the waves come? Like,
I will tell
yeah,
you,
you
I
finish,
will tell you, right? And it might not make sense to you now, but I'll just tell you quickly and think about it. It's actually light. Electricity is light.
Well, I thought
I thought it was
electric-
the I thought it was the stuff
stuff.
inside the
Heat.
wire.
What's heat?
Electrical energy.
The atoms,
It's
the movement,
Protons.
electrons
creates
and neutrons are jiggling.
Again,
Which creates
normally we wouldn't do this.
Oh, no, heat is the jiggle.
the movement is heat because
Yeah.
when you move you get warm.
You remember I was talking about the energy. So we're talking about electrical energy, okay? And I said to you, really, it's light, okay? And then I said, what about heat? So have a guess. What do you think heat is? Heat energy is what?
The movement of the electrons.
Heat energy is the
It's
atom
the movement of the electrons generates heat,
generates.
right? It creates movement, which
Is heat.
But what is heat?
The electric movement.
The movement, the movement.
The heat energy that's created by the movement
Again,
of
The jiggling?
I'm going to tell you the answer, okay? It's light.
Oh, you said that.
So heat is light and light is
Think about the sun too.
Yeah.
Oh,
So
as it gets hotter, as the light gets brighter, does it get warmer?
warmer.
Yeah.
well,
It's like,
let me tell you this, right? We can't see all of the light. Do you know that?
yeah.
Okay.
Okay. Have any of you got a thing called an infrared heater in your bathroom or anything? There's something on the wall, and if you stand in front of it, you can feel warm.
But you can't see the red.
Yeah. Or you stand in the sun and you feel the warmth from the sun, right?
Yeah.
So what the warmth is light coming from the sun that you're absorbing. But you can see the light in all of the colours, so you can see the light bouncing off all of this. But there's other light that you can't see. So snakes, for example, can see infrared light. Snakes can track animals from the heat of their body. So a snake can see you because it sees the heat. Dogs can hear sounds that you can't hear.
Because they have a higher frequency.
Yeah. And there's light that's higher frequency that we can't see, in the same way there's sound at higher frequency that we can't hear. Now all of these things are the same, they're all light. So you might not understand what I'm talking about. I mean, if you do, you're brilliant. You know, I don't understand it, but I can tell you about it. Okay. So the electrical energy is actually really light.
Light, yeah.
But what it is, you might not know, all light is actually a wave. So the thing that makes the difference between a blue colour and a red colour is not because there's blue light and red light.
It's the waves.
It's the length of the
Yeah.
length of the wave that makes it, but it's still just light. Yeah?
Yeah.
Infrared is not a special kind of light that makes you feel warm. It's just that it's
Waves
a longer
are-
wave,
Yeah.
and you experience that as warmth because you can't see it with your eyes.
Like, thanks. If you turn a light bulb for a long time, it heats up.
Yeah,
Is that because?
Oh, like when you touch the light bulb, it's really warm.
yeah.
Yeah.
That's
Sometimes it's really warm.
Isn't it sort of like, it's sort of like a string, so infrared would be like a really long string, and then blue would just be like you bend the string.
It's more like, you know how some days, if you look at water, there's lots of ripples and they're very close together. Yeah?
Yeah.
Other days the ripples are further apart. It doesn't really look much different to you except that the ripples are longer or shorter, right?
Yeah.
But if that were waves, the shorter ripples would look blue. So on days when, if water was light, on days where there were lots of little ripples, the water would look blue. And on days where there were bigger ripples, so the waves were further apart, it would look red.
And
And if they were really long, it would look infrared.
Yeah.
So also, television waves, the way that they send a television signal, a radio signal, Wi-Fi, it's all light. Okay. So if you understand light, you will understand electricity, you'll understand how sound works, you'll understand how radio works, TV works, how electricity and electrical energy work. If you understand the principle, you will understand that all these things are the same. So you've only got to learn about one thing and you will learn all of this other stuff.
Yeah.
Whereas if you learn one thing,
Like how sound works.
yeah, you won't necessarily understand, or, yeah, you won't understand. So what we're trying to do is get you to understand the bigger picture.